Hello everyone and welcome to our YouTube channel. In this video, we'll be discussing another simple ML model. And if you watched the previous one, we did the logistic regression model and we looked at how ML models actually work. So all of how the neurons function, how they're created, what is their idea behind the ML model. And in this video, we'll be taking that idea a little further and discussing classifications models. So last time what we were doing is we were teaching the computer a single equation and predicting what the next output will be. Here we'll be teaching the computer to classify based on some given data. It's a little more complex than a simple prediction via an equation that can be done via normal equations as well. You do not need specific ML model for that. But classification is something that requires smart intelligence, basically. So let's see how the program actually functions. So I have normal imports. So I am using Torch for this, as it supports both GPU and CPU. So I have used Torch here. And this is device is equals to torch.device. So basically what I'm doing is I'm telling the computer to use the GPU, and if the GPU is not available, it will revert to CPU and it will print what device I am using. And then I have x is equal to torch.tensor. So tensor is a type of data type that is accepted by these ML and AI models. They do not accept simple vectors. They only accept tensors. And .to device, so I'm sending it to whichever device that I'm using. And here we have y is equal to, so I need two variables to do anything. And if you can see here, look at the data. So x 1, 2, 3, 4, 5, it goes on to 8. And y is 0, 0, 0, 0, 1, 1, 1, 1, 1. Okay. So what does this mean? So if x is 1, y is 0. X is 2, y is 0. X is 6 or x is 5, y is 1. That means I'm classifying the numbers based on let's say 5. So if they're less than 5, they will be 0 and y will be 0. And if they're greater than 5, y will be 1. In simple terms, either on or it's off. Same way, I'm sending it to the device, whichever one I'm working on. And now comes the model creation. So first we have a linear layer. So I have multiple layers. In the previous one, we only had one. We just had nn.linear. But now we have 4 layers. So first is a linear layer. What it will do is it will take a single input. So 1, 4. So that one means input. And it will generate 4 outputs from that single input. And why is it necessary? Because what we are doing here, it's a little more complex than simple uh, projection or a prediction based on an equation. So it's a little more complex here. And we do not want, we need to use some exponentials here as well. That's why we need to kind of split the input into multiple neurons. Next is ReLU. ReLU is basically, now we are introducing non-linearity in the picture. And it's an activation layer. It's called activation layer. And here we will be using exponentials. So next comes the linear again. So this is for taking out a single output. So I created 4 outputs from a single input. Now I need to combine them all into a single output, back to a single output. And finally, it's the sigmoid function that will convert my output to a probability. And criterion and optimizer all we covered in the previous video. It's the same as in the previous video. Everything here is same as in the previous one. Next, I have a very important addition, which is dynamic input by user for testing. So previously we had inbuilt testing in the program that needs to be modified. That you'll To modify that, you'll need to open the program every time. But now I have integrated it into the program in such a way that when the training finishes, the program automatically asks the user to input some value, input some number, or type exit to come out of the loop. Okay. So when you will enter the value based on the output generated by the probability generated by the model, it will classify the number into either large number or small number. Okay, so let's see the live demo of this. So I'm currently logged into the HPC Paramrudra and I'm inside the GPU node of 15. I've loaded up the environment, activated, I'm using the environment College, and I am using the mini conda module available on the HPC. The program is pretty much the same. The only difference I have made is I have removed all the two device part. So I'm not using CUDA for this. I'm only using the CPU. Since the program is not very complex, using the GPU would actually hamper the performance in this case. So let's compile this program. Oh, sorry, not compiling. We are in Python. So we just run the program. Press enter and then wait. Yeah. So it is printing for every 200 epochs. So epoch 0, we have a loss of 0.7. And by epoch 1800, we have a loss of 0.007. So it's decreased by 100 times. So let's enter a number. Let's enter 5. Yeah, it's a large number. Let's enter 100. Again, it's a large number. It's greater than 5. Let's try 1. It's a small number. Less than 5. Let's try 0. It is also a small number. It is, of course, less than 5. And I can just exit the program whenever I want. Program ended. So this was a very simple classification problem, and it can be extended to some complex problems as well, like classification of, let's say, animals, fruits, even brands, cars, objects, classification of objects, which is a very commonly used type of AI in today. So that is it for this video. Thank you for watching.